Good morning. Good morning, good afternoon. This is Integrated Math 2, and it looks like we're in week 8 of our distance learning, and this week is all about conditional probabilities. So I thought I would just walk through a couple of the problems for this unit. Let's just read through this. So the phrase, the probability event A occurs given that event B occurs. That's what's called conditional, okay? We know the probability that one thing happens based on the condition that something else has happened. And it's written this way, P, A, and then the up and down bar B. This conditional probability sometimes is read the probability of A given B. That's like the shorthand way. So this is 300 students in 11th grade class and their plans for their prom. This is, that's what the title is, okay? So the first question is we're going to be looking at this two-way table and answering these, all right? And we're just going to be answering them to total. Now, the first thing we have to pay attention to is we could add all these numbers up and we would discover this, but there are 300 students. So we know when we find the probability of some of these things, we're going to be having to use that total 300. Let's just write this here, right down here, because this is what it's going to look like later. So 300, all right? And that is our total number of students, okay? Total. So let's put a title here. Totals. Okay. Boom. Okay. So total number of students that prefer a hotel. Well, that's 73 and 55. So I think we need to even do a little bit more math and add up these numbers, right? So 73 plus 55. What's that? So let me go to my Google. Okay. And let's say equals 73 plus 55. 128, okay, so 128. So my total here would be 128. So our probability that we prefer the hotel would be 128 out of 300, okay? 128 out of 300, okay? And maybe we need to do something like a little different just to make this all fit on the same screen. So like this, and then this can be smaller, maybe. So we can have our calculator over here. Maybe we can make that work. We'll see. Let's positive thinking here. Positive thinking that this will all work. All right. So let's move this over. Maybe, it is what it is. Okay, so 128 divided by 300 equals, okay? And we get a number answer for that. And the number answer we get is 0.42. Our 43% equals, so we get the number answer here is equal to 0.43, or 43%, or about 43%, okay? Prefers the hip-hop band, so we have to do the same thing we did here, where we found the total. There's 73 that prefer hip-hop, and and the hotel, and 80 that prefer the recreation center and the hip-hop, okay? So let's see. So we have to total these up together. So let's go back to this. Okay, so we're going to add up 73 plus 80. All right, and what do we get when we do that? I wish this looked a little smaller. 153. So our total here would be 153. So we know that the prefer the hip hop band would be 153 out of 300. Okay, which would be, let's figure that out. 153 divided by 300. And we got a number answer, 51%, okay? So we get equals 0.51 or 51%, okay? Okay, let's see, prefers the hotel and prefers the hip-hop band. So so that would be this section right in here, prefers the hotel and the hip-hop. So 73 out of that 300. Okay, this is out of everyone still. There's no conditions being given yet. This is kind of like a little bit of a review. So 73 out of 300. And we would just do the math to figure that out. So 73 divided by 300. All right, and we got a number answer, 24%. So 0.24, 0.24 or 24%. Okay, all right. So that's way too big. All right, so let's take a look at our next number. Prefers the hotel or prefers the hip hop band. Okay, prefers, so either one. So they can like the hotel. So now we're expanding this to anyone that likes the hotel. Doesn't matter what kind of music. or anyone that likes the hip hop band. It doesn't matter where they want it. So basically everyone except for this classic rock and this that recreation center. So it prefers or that. So we would add all these up: 73, 55, and 80 out of 100. Now we're not going to write that down anywhere because I think that would look confusing. So let's just say, so we would add up 73 plus 80 plus 55. Okay, we get a number answer for that, and we get 208. So this would be 208. 208 out of 300, and we would just take that number, right, and we're going to divide that by 300. It's like the movie 300. Remember that movie? 69%, okay? So we end up with this is equal to 0.6669 or 69%, okay? So that kind of is a little bit of a review, and now we're going to talk about this new condition that we have here. Sorry, it took me a whole 6 minutes to get to it. But our condition is that what is the probability, let me get rid of this, that they prefer the hotel if we already know they prefer a hip-hop band. So we know we're looking at only this data right in here, and this is where sometimes when I go to write with this, it gives me an issue. Only this, we know they prefer hip-hop, so we're looking at only this row, okay? So we're looking at, well, we're looking at how many, so prefers the hotel. In this row, we only have 73 of them out of how many are in this row, which we already added up to be 153. So this would be 73 out of 153. Okay, and that's the math we do. So you notice now we're not dividing by, we're not dividing by what's it called? 300 anymore. Okay, so let's see. So 73 out of 153. So 73 divided by 153. Let's get a number answer, 47%. So 0.47, or let's call it 0.48. 0.48 or 48%. Okay? Now let's see our next one. They prefer hip-hop band, given we know they prefer the hotel. So we're now what we're looking at looks a little bit different. Now we know, what we know is they prefer the hotel. So how many of these students prefer the hotel? And of the ones that prefer the hotel, how many of them want a hip-hop band? I'm trying to think of what hip-hop band would come in at a prom. Okay, so we're only looking at this row. So we already found out our total is 128, so we know we're going to be dividing. They prefer the hip-hop. Oh, man. Brakes. Put on the brakes. I made a mistake. Never mind, I got in my head over that. Okay, so we know this one they prefer the hotel, so we're looking at this as our total. So it's going to say out of 128 here. And how many of those prefer hip-hop? Well, that's just 73 out of those. So we would divide that. So this one would be, instead of having 73 out of 153, it's going to be 73 out of 128. 128, okay? And we're just got to redo our little maths for that. So let's see. So 73. Oh, let's where is it? Where are you at? Okay, 73 out of 128. Okay. And 57%. So 0.57. 0.57 or 57%. Okay? So this is kind of how you would interpret the two-way table to figure this out, all right? So let's take a look at our next one. So what do we do here? Prefers the hotel. So I'm wondering if we can like write a little statement. So prefers the hotel given hip hop. Now what did we do? We divided something. So we divided at the top, we put the 73, which was what? Both the hotel and hip hop, right? The probability, oh, I want to put a new one here. The probability of the hotel and hip hop, okay? And then we divided by that by what? The probability of just hip hop, okay? So we maybe can come up with a little formula for this, right? Maybe. So let's just move this all the way over. That's going to take too long. So let's say we have a formula. We probably could write a formula. Ooh, let's write a formula. Formula box. Let's do it here. Let's give it a color, green, okay? Probability A and B, okay, is equal to, and hopefully I don't mess this up, is equal to, it looks like it's the probability of B. We know that we're restricting this to only the probability that that second thing happens and the probability that both of those occur. So probability, oh, I don't want to put that there. Let's do a note box. Probability A and B, okay? All right, this is kind of like our definition, and we might use it a little bit later. All right, we're getting up to 10, 11 minutes. Let's take a look at the next problem. Let's decide if we have time to go through it. So, oh, here we go. All right, so here we're talking about rolling dice. Yeah. Which do you think is higher, the probability of getting doubles or the probability of doubles the sum is 1? Yeah, let's dive into this on the next video.